Thank you for joining us for this webinar. I'm sure, like us, COVID-19 has led to the cancellation of some, if not all, of the trade shows you've attended in 2020. Today, we'll be discussing the latest from NVIDIA Networking. NVIDIA Networking connects users, servers, and storage with faster and smarter fabrics using Ethernet and InfiniBand technologies. But before we jump in, I wanted to briefly cover who Boston are, in case you're not already familiar with us. Boston Limited has been providing cutting-edge technology since 1992 using Supermicro building blocks. Our high-performance, mission-critical server and storage solutions can be tailored for each specific client, helping customers to create their ideal solution. Boston are a global company with offices across EMEA, India, the USA, and Australia. Boston offers a number of important benefits to our customers, including end-to-end support from rack scale design to networking cabling and installation from the edge to the data center. We assist our customers in finding the perfect solution by testing solution configurations in Boston's research and development facilities called Boston Labs. And you can leverage Boston's expertise and extensive consultancy services to solve your time-sensitive issues and ensure workloads run optimally across all your systems. And finally, we'll help you to scale quickly with workload optimized solutions. As with all of our presentations, we'll be undertaking a Q&A at the end of this session. So if you have something you'd like to ask our presenter today, please click on the question mark icon in the Teams app and type it in. Time permitting, we'll answer as many of these as we can during the event. So let's get things started. I'm going to hand over to our presenter today, Gadi, to tell you more about today's topic and a little about himself. Gadi, over to you.
So hello everybody and welcome to this session where we will be talking about the future with NVIDIA networking. I am Gadi Godanyan. I've joined NVIDIA as part of the Mellanox acquisition. I've been working for Mellanox for the past 8 years or so. Started as a QA support engineer, and as the recent job as part of the UKI team as a senior system engineer. So let's dive into it. We'll be talking about the networking vision from NVIDIA, and then we'll do some deeper dive into some specific components like the switching, Ethernet or InfiniBand fabrics, the ConnectX card, and then the DPU, the data processing unit. We'll talk about some use cases, and then we'll have a quick Q&A session. So keep your questions, write them down, and shoot those at the end at me. So the idea behind a lot of the changes recently when it comes to NVIDIA, and those changes are actually the acquisitions of several companies and the introduction of new products in order to basically reinvent the data center. This is how we look at those technologies and at those acquisitions. And the idea behind it is that Moore's law is dead and the data center is the new unit of computing. So you don't need to look at it anymore as a single component, but the entire data center is actually the compute unit. So on one side, when it comes to NVIDIA, we've been doing for years and years now are the GPUs actually. So accelerating AI and machine learning. And then on the other side is taking something that is called a DPU, the data processing unit, which will be able to run software-defined, hardware accelerated capabilities. So basically push to the hardware a lot of the capabilities that we will talk about in the next slides, and by doing so, accelerate the performance of the actual server, CPU-wise or GPU-wise, and this is the vision. So how are we going to do that? We're going to do that the same way that we've been doing those things for years now. So this is an easy one. We'll just continue doing what we're doing best, and I will talk about it. So first thing, if we'll start from the left side, is the fact that we'll use one architecture to control everything in the data center. And I'm sure that a lot of you are familiar with CUDA, which is basically our infrastructure for SDKs and APIs, where customers and end users can come in, get the latest open source capabilities, develop on top of that, use this installation, develop on top of that, and then increase the performance by putting their own code on top of that and pushing it back to CUDA. So basically you have one architecture, it's always backward and compatible, where all the code is being used in order to use those software libraries to further enhance the hardware of the GPU from NVIDIA. And if you take a look on the charts that gives you the performances from our GPUs, you can see that we have leaps in performance even when we don't use new hardware, just by using the software that the community and our developers are writing into CUDA. The second pillar is continuing thinking about the largest scale possible. So from single entity, single compute unit to the largest thousands and tens of thousands of nodes working together seamlessly as one data center. The third area that we are focusing on is the fact that we've been looking after those X factors for speeds ups in the data center. And this is why we no longer look at those entities as a CPU, GPU, but as a whole data center itself. So simple things that Mellanox introduced, like something which is called GPU Direct. We won't go too technical on this session. If you want those information, I'm more than happy to share. So an example of GPU Direct is leveraging RDMA, basically remote direct access memory based interconnect and application, in order to bypass the CPU every time and incoming traffic is getting into the server. So basically we can write the relevant information with zero copy directly into the GPU without using the CPU as a bottleneck. So this is one example of those X factor, or doing things which are called in-networking compute, basically using the switches which are sending the traffic in the network to do some of the hardware capabilities themselves, because the traffic is already going through the switches anyway. So these are the X factor speeds up. And then the last one is the fact that we have a full stack when it comes to the data center networking. And this is also part of those acquisitions. So we talked about the development as part of CUDA. You will hear a new term today, which is called DOCA. It's the same as CUDA, just for the DPUs. And we are focusing on accelerating whatever we can with hardware-based acceleration or software-based acceleration, running on top of our compute. And then, of course, everything is being deployed on top of our networking stack, which we will talk about in the next slide. So NVIDIA Networking, a deeper look inside. So basically we have four main areas, right? We'll start from the left side. So switches, either in InfiniBand for the 400 gig technology that we are introducing right now, or in the Ethernet technology, which is 200 gig, which is G8 at this point. The adapter, the latest one available is Connectix 6, so the actual network interface cards. Again, 200 gig Ethernet cards. The DPU, the data processing unit, which is basically a Connectix card with ARM cores on top of, or ARM cores plus a GPU on top of, which we'll discuss in the later stage of the presentation. And then, of course, the cables, transceivers, the optics, which actually gives you the end-to-end solution when it comes to the networking side. And on top of that, we need to consider the fact that we also have a lot of software. We'll talk about it in the next slide, but those are like the basic components. And in this presentation, we were focused more around the switches and the adapters and DPUs. So, okay, let's take a deeper dive at the switches. We'll start with Ethernet. So this is the Mellanox Ethernet portfolio. This slide is not here for us to go into the details of the different port speeds and port combination. It's more of a slide in order to show you where Mellanox plays, and basically the fact that now we have a full portfolio when it comes to the Ethernet switches. So from half width very unique form factor switches that you see on the left side into full-blown super spine 4U switches that gives you a massive scalability. So again, we won't go too deep into each and every one of those switches, but it's here for you to take a look at and understand what are the flavors that we have. In front of you, you see 3 different generations: Spectrum 1, Spectrum 2, and Spectrum 3. Spectrum 1 and 2 are GA, Spectrum 3 are coming soon. And the differences between each other are basically the feeds and speeds. So moving from 100 gig based platforms to 400 gig based platforms, and the scalability moving from a maximum of 64 ports per switch up to 128 port per switch. Everything is backward compatible, and we are not vendor locking. So basically, you can run whatever cable and transceiver you want, and we won't lock it. There are no hidden licenses. What you buy is what you get. And we are open in terms of open networking. This is not the main topic of this discussion, but this is definitely an important aspect. The fact that you can run different flavors of operating system. Mellanox OS, which is called Onyx, Cumulus OS, which is part of the NVIDIA recent acquisition of this year, which is a more larger scale based operating system based on Linux stack, and Sonic if you want to go full open standard and adopt Sonic as your operating system. So this is part of the Ethernet portfolio and vision when it comes to open networking that we've been doing as a company for years now, for I think 7 years since we opened the switches, or 6 years. So some other benefits of our silicon, if we're talking low level hardware capabilities. So we have a leading performance when it comes to packet and burst absorption, just because the way that the silicon is being manufactured. So we have a shared buffer architecture. That means that all of the ports share the same buffer, compared to the most deployed buffer architecture in the market, which is actually the split buffer architecture. Again, we won't go too deep into that, but those are things to remember when we're talking about Mellanox. Fair bandwidth sharing, again, it's also being driven from the fact that we're using shared buffer architecture. And we have the lowest latency by design, because we understand how important latency is for storage, machine learning, and HPC. By design, compared to the competitor, we have the lowest latency in the market when it comes to the full-blown layer 2 and layer 3 switches. Let's talk a little bit about the software. So basically, what we believe in is the transformation of the networking industry is moving forward. We're learning more and more from the hyperscalers, and the idea is to reduce the cost as much as possible, to automate as much as possible, and to remove the human factor from the deployment parts and the debugging part. So everything is automation driven. Everything is being driven from the DevOps point of view. Everything is containerized and built for microservices. And again, all of this represent a shift in mindset. So it's no longer CLI based. It's no longer like the old days when you go and log into each and every switch and take a look at the massive configuration line. Everything is automated. And Cumulus is the best operating system to use when you're putting this DevOps hat on. So that's enough on Ethernet. The beauty of our networking stack is that you can choose Ethernet or InfiniBand. Each one will have its own benefits. In a lot of the cases of AI and machine learning, we can prove better results with InfiniBand. But this is something that is the customer preferences, and NVIDIA are looking much wider into the data center. So Ethernet and InfiniBand both have their own place in the data center. So when it comes to InfiniBand, right? What does it bring to the table? First of all, the complexity is not on the switches and on the network. So the endpoints are the smarts units in the data center. That reduces a lot of the complexity from the networks and brings a lot of capabilities, like I mentioned earlier, GPU direct into the server. And then, so the smart is at the endpoint. So two things give you more flexibility and capabilities on the end node, on the servers or the DPU, and keeps the network much simpler. Like NVIDIA are looking at the data center, InfiniBand was also designed for scale. So the entire idea behind the InfiniBand is to look at the maximum size and the largest size of the biggest supercomputing in the world. And InfiniBand is designed for the largest scale possible. InfiniBand is an SDN, software-defined networking-based solution. So that gives us the ability to have central management unit to control the entire fabric. This, again, simplifies a lot of the capabilities of the network. For example, your switches don't even need to have CPU with InfiniBand in order to reduce cost, because the mind behind the network is actually sits in the SDN controller or at the end nodes themselves. And then the fourth item is the fact that InfiniBand is an open standard being development by the InfiniBand Trade Association. Everything is forward and backward compatible, and Mellanox have been playing in this market for years, for 20 years or so. Okay, so most of the bigger deployment when it comes to the NVIDIA DGX that I'm sure you all are aware of are based on InfiniBand. Some of the uniqueness when it comes to InfiniBand are here on the screen right now on this nice picture of our turnkey DGX superport solution that you can see in the background. So the fact that InfiniBand gives you some capabilities like in network computing that accelerate HPC and deep learning application. Again, this is like X factor that you get by combining NVIDIA with the NVIDIA networking solution coming from Mellanox. When it comes to the actual interconnect itself, InfiniBand gives you the fastest data throughput. So we're now talking about sampling and of NDR, which is the 400 gig based card and switches with extremely low latency. InfiniBand latencies are really low compared to Ethernet, so it really depends, but on the speed and the generation, but you get much lower latencies. And for whoever it's relevant, we can provide those performance results. And as I mentioned before, backward and forward compatibility with the InfiniBand generations. So let's take a deeper look at the InfiniBand portfolio, right? So first of all, you'll have the ConnectX card. For every ConnectX card, you'll have Ethernet version for it and InfiniBand version for it. We won't take a look at those different naming, but this is something that you need to remember. So it's a 200 gig base adapter with 600 nanoseconds of latencies. Everything is backward compatible, doing up to 200 gig, as I mentioned. Quantum switches, those are the 1U based silicon that gives you 40 ports of 200 gig or 80 ports of 100 gig InfiniBand, again with much lower latency that Ethernet. We can see less than 100 nanoseconds of latencies. BlueField, which is our system on a chip, our DPU, which we'll talk about in the coming next slides, that gives you this edge in terms of what you can run on the server without the server being even involved. And then, of course, the LinkX business unit, which is our cables and transceivers that we manufacture ourselves. And then, of course, everything is incorporated into the NVIDIA AI and machine learning beasts, which is the DGX A100. So DGX A100 will leverage application levels capabilities like GPU direct, and then hardware capabilities like the ConnectX 6 network adapters, which gives us the ability to run with 200 gig cards. So moving forward, just a quick look at what we see in the next generation of InfiniBand when we're talking about NDR 400 gig, which is being introduced right now in terms of is being revealed to the market. I just took two examples of scale data centers with 1,500 GPUs or with 4,000 GPUs. So you can see that we are breaking our own records when it comes to the networking benefits and the networking cost and the networking deployments of InfiniBand with NVIDIA GPU on top of that. So you can see massive cost saving and power savings when you take NVIDIA Networking InfiniBand and incorporate them to a massive scale out GPU clusters. So that's enough on the switches. We'll now focus on the networking side of the network cards. And before we jump into the DPUs that a lot of you are here to hear about, we need to understand that every DPU is being deployed will have a ConnectX card in it. And the secret sauce is actually in the ConnectX card itself, because this is where the hardware capabilities, the hardware offloading occurs. So it all starts with a core ASIC design from Mellanox. So we have been designing our silicon from ConnectX 1 from 2.5 gig lanes and up to the 400 gig that we're working on right now. So many years of ASIC and hardware company deployment. So on top of those ASICs, we'll have different kind of form factors for the network interface card. So from PCI stand-up, Gen 3, Gen 4, Gen 5 PCI connectivity to OCP2, OCP3 connector types. And then on top of this hardware, we'll have a software ecosystem coming from open standards and open source initiatives in the market. So all of the top distributed kernels, even Windows is supported on top of our cards. Open standard the performance kits like DPDK or Rocky, which is RDMA over converged Ethernet. And then we believe in the open story. We mentioned it many times before. So every code that we write on top of our NICs are actually being prioritized upstream first. So if 6 years ago we were prioritizing our own software stack, which is called Mellanox OFED, now everything is being pushed upstream first, and this is where we see a massive accelerators from our software and from the open standard of the community on top of our NICs. And then each specific technology and capability will fit a specific vertical or underlying technology in the market. So for every specific vertical, for every specific technology, we'll have the underlying capabilities in the software and on the hardware of the NIC. And again, the massive benefits are actually coming from years of us putting hardware capabilities into the Mellanox NICs. Let's take a deeper look on the latest GA card from Mellanox, which is called ConnectX 60X. So I put here some capabilities. I won't go too deep into them. It's more of like one slide to show what ConnectX 60X is made of. But what we need to remember is the fact that a lot of those hardware capabilities, like you can see in the second bullet, like it's mentioned as crypto, data in motion, those are hardware capabilities that we can do in the silicon itself, like IPsec, TLS. So that means that the card itself can offload and perform 100 gig IPsec offload capabilities in hardware. That meaning by not having any hits on the CPU of the server itself. And this is probably the most significant benefit of the DPU that we'll talk about in the next slide. So the fact that we can hardware offload to the NIC itself without impacting the CPU of the main server. So introducing the DPU, the data processing unit. The idea is to have software-defined data centers everywhere as part of your infrastructure on a chip. So the idea is to take management and storage, security, and networking, take it outside of the CPU. So in the middle side of the screen, you can see the CPU running VM containers in blue, and then the CPU is also responsible for those storage network management, security, software-defined security, all of those capabilities, all of those extreme benefits are being done today in a CPU. That means that it's consuming cores and it's not efficient as to do it, like you can see on the right side of the screen, in the network interface card itself, in the DPU, you can see it in purple. So the idea is to push whatever we can from the CPU itself, freeing up more cores to run the VMs or containers, and by doing so, putting the load on the card, on the DPU itself. This is why we're calling it offload capabilities. Offloading whatever we can from the server to the network interface card, or basically to the DPU. And who is going to do it? How are we going to do it? So let me introduce you to the next to the workhorse of the new data center, which is the BlueField DPU, the data processing unit. Basically, what you get is a Connectix 6 card with PCI connectivity, with the same 100 gig ports, but now this card also have an ARM cores, 8 ARM cores on top of that, to manage all of those capabilities and to separate this card, this DPU, from the main server. So basically what you're getting is a new server in front of your real server, when you can control the amazing capabilities of the Mellanox NICs. So if, for example, we talked about IPsec earlier, when running Connectix 6, in your server, the server needs to be aware of the IPsec encryption and decryption whenever you're running Connectix 6, because someone needs to handle the crypto keys, and somebody needs to handle the fact that the card is actually encrypting. And that means that if you're putting a Connectix card, for example, in your server, the server needs to be aware of the encryption going on. But if you're using the DPU instead, now everything can be handled from the ARM. So we'll have 1 gig management to the ARM cores, and the server itself can be not even aware to the fact that the DPU is actually encrypting with IPsec or TLS in line rate without affecting any performance seats on the traffic. So data not data in rest, data in motion, without the main server even understanding that this is what's going on. So this is the power of the ARM cores running on top of the Connectix card as part of the BlueField. The idea is not to do the crazy things in ARM, because the ARM is pretty weak. The idea is to use the ARM for management of the Connectix card with micro-segmentation from the real server. That's the beauty, that's the power of the DPU. Leveraging the hardware capabilities of the Connectix card by not affecting the server at all, by only using the ARM cores and not the 886 server. We have some more examples here on the screen. So 100 gig IPsec, 50 gig regex. This is part of another acquisition that we had last year or 2 years ago, which is now incorporated into our hardware capabilities. 100 gig video streaming with a library called Rivemax, and some high-op improvements when it coming to NVMe for our storage accelerations. So I quickly want to mention a new card that NVIDIA have announced a few months ago, and this is to further show how NVIDIA and Mellanox are now incorporated into one. So introducing the BlueField 2X, which is basically BlueField 2 with not only ARM cores on top of, but also a GPU A100 Ampere on top of that. So that means that you now can also apply AI in real time into your network traffic. We won't talk too much about it. It's a Q2 2021 card, but just to give you the idea of where NVIDIA is going, the idea is to make your servers, make sure that your servers are working on the money maker of the organization, when all the fancy stuff and all the enhanced capabilities are done on the NIC itself, by lowering the costs and also by improving the security, storage, and network capabilities. So we talked a little bit about the hardware, and as you know, in InfiniBand hardware, in NVIDIA, hardware is super important, but without the software on top of it, we don't have it. It's just worth nothing. And like NVIDIA had a massive success with CUDA, I want you to learn and understand that we have introduced a few months ago Docker, which is the data center infrastructure on a chip again, but now with all of the Docker SDK and API libraries open to the market and to our customers and partners. So basically now those customers can develop on top of the DPU without fearing any backward compatibility or any interoperability issues. So you have one open source API infrastructure that incorporates programmable capabilities like P4, SPDK for storage, or DPDK, while leveraging and keeping the capabilities that we introduced to the market, like telemetry, what just happened, or management capabilities that we've built on top of our Connectix cards. So Docker will be the main driving force for more and more application and more solutions on top of these amazing capabilities. Just to keep some perspective and show you some value on things that we have been working on. So I want you to take a quick look on the coming slides. So we just picked some capabilities and compared them to running it by hardware on the DPU instead of doing it in CPU, consuming cores from the main server. So you can see here some malware pattern matching. By doing it in hardware, you can get 10 times the performance, IPsec encryption, video streaming, storage, elastic storage, block storage, and so on and so forth. So basically, you're doing it in hardware, so you're doing it much more efficient, and you're saving CPUs, and you're getting this micro segmentation where the server and the DPUs are now two separate units for management. So you're gaining much more than just only increasing the performance on your DPUs. So I think we're ready to take a look about some use cases. And the next slide will talk about it. So when it comes to use cases, we have three pillars, right? Three main areas at this point, and I'm 100% sure that this will expand the more we go with the DPU into the future. There are many other companies that claim and that they're saying that they're doing GPUs and they may have some baked solutions already. None of them is as wide in terms of the hardware technologies and capabilities as the NVIDIA GPU solution. And we have three pillars: the software-defined networking, so anything like virtual routers or virtual switch, which is incorporated for many years now into our NICs. Our ability to do things like NAT load or load balancing in the NIC itself by leveraging Open vSwitch, for example, running VM or containers on top of that, and then running telco solutions, which is not only now being used in telco for an NFV solutions, for example. So all of those network-defined solutions, things like tunnel building and encapsulation and decapsulation, VXLAN, all of those things can be done in the DPU itself in order to offload capabilities from the NIC. And we'll take a deeper look at some of the use cases. Same goes for storage-defined network and software-defined storage. Those are the capabilities from the storage pillars. So NVMe over storage fabric. So for example, emulating a remote storage as if it was local to the PCI. So the server itself is not even aware that the storage NVMe a unit is not located locally to the switch. The DPU can emulate that. The DPU can support it on top of Linux perfectly, or on top of Windows, which do not even have the capability to do NVMe over fabric. Data encryption, all of those storage capabilities. And when it comes to the security, there are massive capabilities and hardware offloads being developed in the being incorporated into the Connectix 60X, and you can see them here on the screen. So how are we going to do that, right? So we have the hardware, we have the software, we've introduced Docker. We see three ways of implementing the solutions on top, our solutions on top of the DPU. The first way, the first capabilities, or the first approach, which is available today, is taking the DPU, the BlueField DPU, which is GA since the last few months, use the Docker SDKs in order for the customer to use their own application to run on top of that platform. So it can be you as customer building your own next generation firewall by allowing and not allowing specific flows that you choose to do, right? It's you, the customer from the FSI market, deploying your own solutions that are giving you the ability to shut down traffic or graceful shut down traffic from the stock exchange in some cases, or customer app that Mellanox built, like something called Snap for storage emulation. So those are, I would say, a bit more sophisticated customers or sophisticated solutions where there is a big involvement from the customer to deploy an actual solution and build an actual code on top of the Docker SDK. It's available today. Those SDKs are available today from OVS to DPDK and so on and so forth, or the Mellanox built, the NVIDIA built customer application. Now, for the enterprise market, you see VMware now on the screen, and you're probably thinking, wait, what's going on? So we've introduced, and the next slide we'll talk about it, a partnership with VMware where they will push all of the NSX capabilities into the BlueField in order to give you more cores to work on your business. So we're talking about an example of a VMware-based solution. So basically, when you'll buy the solution and the license from VMware, you will already get all the goodies from the BlueField. So for you guys right now is understanding that the BlueField is there, but you will consume BlueField as part of an enterprise-grade solution from, for example, from VMware. And then, and this is, we're talking about 2021. And then the last pillar or the last approach for Docker being developed on top of BlueField is third-party applications. And these are things that we've been working on since the beginning of the year. And I will talk about also in the next slide. So basically taking third-party applications like Fortinet or Palo Alto or other vendors or Guardia Core applications, solutions that have been integrated to run on top of ARM and use that as part of your actual solution. So basically you will buy it from third-party solution, a license scheme to run on top of our DPU. Instead of doing hardware-based, appliance-based, for example, a threat detection, you will be able to use one of the security companies to run a software-based solution on top of our DPUs, which leverage the hardware capabilities of the NICs. So let's take a deeper look at the VMware announcement. So VMware have announced the next generation cloud foundation architecture from their called Project Monterey. So on the left side, you can see the traditional way of just having whatever NIC and run all the smart capabilities in the ES6i. Again, the problem is you're consuming a lot of CPU cycles for it. So the idea is to keep the hypervisors, some of the hypervisor capabilities on the ES6i, but with leveraging the DPU, take all the network security and storage and host management capabilities and push it to the DPU. That way, you can run a much more efficient cloud solutions from VMware. Again, by keeping the ES6i as simple as possible on the CPU side, but offloading most of the capabilities and porting the ES6i to actually being able to run in the ARM cores of the network interface card or of the DPU. How are we in terms of time? Perfect. So moving forward, so we talked about the enterprise ready. So this is the NVIDIA VMware vision. If you have any specific question on that, we can go deeper and we can present and show some numbers. And the third pillar that I've mentioned is the growing ecosystem of the DPU. So storage, security, infrastructure. You have some names over here that we're working on with in order to put the DPU as part of their third-party ecosystem, so they will be able to run their solution on top of our DPU. So I've been personally involved with some of the names here. So Again, from storage, you can see here some names from a security side of the business. You can see also some names. And then when it comes to infrastructure, just a quick example, we have Canonical here, where they have a solution called Metal as a Service, basically for you to run your on-prem cloud on like it was in other public cloud infrastructure. So for example, an infrastructure example running on DPU can be spinning up DPU as if it was any other server as part of your Metal as a Service solution from Canonical. So this is just an example. Something I forgot to mention, the ARM cores of BlueField will run Ubuntu by default, but you can run whatever OS on top of that as long as it supports ARM, of course. So basically, it's any server in front of your server running Ubuntu, for example, and you can port and you can put whatever ARM-based application on top of that. And just to give you the last example, when we're talking about the third-party solution, Mellanox is now working on running our own operating system, the Cumulus operating system from NVIDIA on top of the DPU. That way, we will be able to give you the ability to have layer 3 stack routing on the host from your DPU without the server even noticing it. So you can be able to leverage things like EVPN, IPsec, or Ansible configuration from the DPU itself without the main server being even aware of those things. So you'll have zero trust, a boundary domain between the server administrator leveraging the actual server itself to the network administrator, who now not only own and stop in the top of rack, but stop in the network interface card and being able to port all of those more advanced capabilities of, for example, VXLAN or crypto into the networking team from the server team. So basically, just to wrap up, this is one slide to show you how Mellanox incorporate into the massive NVIDIA story. So as you can see, the NVIDIA story is much wider than the bits that we've just introduced right now. So the idea is to use our hardware and software capabilities coming from the Mellanox acquisition in order to, at the end of the day, leverage and make the NVIDIA machine learning and AI story much more efficient. So I won't go, of course, to over the items represented in this screen, but this is the full picture from NVIDIA from the bottom up. So we've been discussing mostly at the hardware level and then a little bit at the server cloud level. But on top of that, NVIDIA have been working for years and years now to develop this very wide ecosystem. So we're right on top, 41 minutes or so. We have 5 more minutes for Q&A, so feel free to reach out to me right now in chat or in any other method and ask any question that you want. You can also feel free to reach out to me after this session by email or by phone. All of my details are in the session. So thank you so much and see you soon.
Okay, so we're now moving, as Gadi says, over to our Q&A portion of the webinar. If you want to click on the icon with a little question mark in a speech bubble in your Teams app, whether you're on you're viewing it in the Teams app or whether you're doing it via web, it should still be the same icon. You can type your questions in and Gadi will answer us. My name's Maz Lopez. I'm head of marketing for Boston. Sam, unfortunately, who was with us at the start of the webinar, has had to be called away. So I'm taking control of this part of the webinar. Gadi, are you there? Can you hear me okay?
Yes, loud and clear.
Perfect. So to kick off, can you elaborate why someone would like to run Cumulus OS on a server?
Yes. Okay. So great question. Basically, for many years now, we've been playing with, as an industry, as the open community in the industry, with the idea of running layer 3 on the hosts. Now, there are not many user who went through this route, actually, because there was some issues around who is going to support that and how complex is routing a layer 3 on the host. But basically, Cumulus now, as part of the DPU, is giving a real solution for that. So you can get and run a full layer 3 supported stack from Cumulus with our support on top of your host without it interfering with the host itself. So the most basic and obvious thing is being able to reduce completely your layer 2 network, because now the host itself will also run BGP instance. And when I'm saying on the host, is actually on the DPU, so it's actually separated from the main server. So this is one of the reasons. The second reason is the fact that now, in terms of the management of the network team take most of the complexity of actually managing the network, because the responsibility line now includes the server also as part of the network team. So that things makes much simpler way in terms of configuration, because nowadays it's being split between the networking team and the server team, because the server team needs to adapt the network requirement. When running Cumulus on the DPU, the network team can take control over the DPU without taking control of the real server, and by doing so, you have one team responsible for the full end-to-end network capabilities. So this is probably the best reason for why you're doing so.
Okay, fantastic. Another question here is, I'm interested in deploying IPsec on each host. How would such a process work? Okay,
brilliant. So so we all know that once we are moving to 100 gig, some of those appliance-based solutions for security, let's say use IPsec, in that example, can be very costly, and also we don't want to just deploy them at one location in the network, and ideally want to deploy it around the network in order to secure east and west traffic as well. So basically, how will such thing will look like? First of all, we're here to work with our customers and end users, right? So the ability, the hardware capability is there. First step will be reaching out to us. I will arrange a demo where you can log into a system that we've built, and we can show and prove how the IPsec can work with 100 gig ports by doing the IPsec encryption on a data in motion and not in data in rest. That means that you will have no packet loss, no packet drop on 100% of the load. So that will be the first stage. We'll go into like a proof of concept stage where you can see how we deploy it, and you can see the information on our side. Then we can ship you a BlueField card to BlueField card, so you can do those tests by yourselves between your devices. And we will be there in order to support you with that process. Sometimes those things require a bit of more complex approach, and this is why Mellanox or NVIDIA, we're here to help you with that process. So we have the documentation, we have the lab processor that we can share, but we will also be more than happy to send the cards and work with you in order to establish those capabilities on your actual production deployments.
Okay, perfect. I'll just give it another minute just for any last questions to come in. But thank you so much for joining us today, Gadi. It's been great to work with you on this webinar. I think there's been so much fantastic content here. Anyone that could have joined midway through, we will be providing you with an on-demand link, so you can always watch back at any time you need. As Gadi said, he's available for any questions that might spring to mind post-event. You can email those through to marketing.promotions@boston.co.uk. You can reach out to your sales executive at Boston, who will be more than happy to organise any test drives that you may like, or loop you in with Gadi and then the other team at NVIDIA Networking. Okay, there's no more questions, so I think we will wrap it up just before the top of the hour. Thank you again, Gadi. It's been a pleasure to have you.
Thank you very much.
And thanks very much to our attendees for joining us today. We look forward to you joining us for another webinar, hopefully in the near future. Thanks.
Cheers. Bye-bye.